Okay, what we're looking at here is the bell housing area of the GM F40 transaxle, and as you can see, I removed the throwout bearing. Here is the input shaft, and please note that if you remove the throwout bearing, it has an integral seal on the back side of it that seals the transmission case to the input shaft, and you don't want to get any dirt in there or you'll ruin your input shaft support bearing. And to replace that bearing, you'll have to take apart the transmission. One of the things I needed to do was figure out what the depth is going down into the bell housing, basically to the flange mating surface of the transmission, the flange mating surface for the throwout bearing, that is, and I'll show you why I needed that dimension in just a minute. So I found the depth here, and let's see, that depth is 124.6 millimeters to 124.8. So 124.6 to 124.8. There's a slight variation due to the machining tolerances of GM. And so then come over here to the engine, and as you can see, I've installed the flywheel, the pressure plate, clutch disc is sandwiched in there, and you can see I've rigged up the throwout bearing on a frame, and this frame is meant to represent the transmission bell housing. Here is the flange mating surface, this surface right here, and that's butted up against this piece of steel, and I made a little cutout to make room. By the way, I blew out this rear seal because I didn't know that it would pop out when I put pressure on there, so I had to put some additional steel back there to back it up, and that was pretty tricky getting that just right, because I needed to have this surface right up against the steel bar, because I'm measuring from the steel bar, the edge of the steel bar, to the face of the engine, which is where the bell housing mates up to the engine block. So the other thing that I have to account for, and this is true for any clutch, is as the clutch disc wears, it becomes thinner, right? So as it becomes thinner, the fingers of the diaphragm are going to move slowly outward. And so if you, this throwout bearing is a bit unusual because it's designed to be pre-compressed when it's installed. Normal throwout bearings, or at least the old style, the old school way of doing it, they didn't do that. But at any rate, this one is pre-compressed, but I had to allow for the fingers to be able to drift outward as the disc wears and becomes thinner. And as you can see, I've got quite a bit of space. I figured out that the fingers, by the time the clutch disc is fully worn, that's, you know, presuming full life of the clutch disc, the fingers will be sticking out of the top of the pressure plate by about 0.2 inches. So I needed the throwout bearing to have enough room to allow the fingers to move all the way out. If the throwout bearing bottomed out before the clutch disc was worn completely out, then we'd have a problem. We wouldn't get the full mileage out of that disc. So it's super important to get that dimension correct. But at the same time, I had to pre-compress it enough, pre-compress the throwout bearing enough so that when I push the clutch in with the clutch pedal and disengage the clutch, that there's enough throw, enough travel in the throwout bearing to push the clutch fingers all the way in and cause the disc to fully release. And so getting all that right is actually pretty difficult. My initial calculations, I tried to calculate this distance initially, and my calculations were way off. It turns out that the surface, this flange surface, you remember in the transmission, this throwout bearing is normally at 124.6 millimeters, and let me make sure that's right. Yeah, 124.6, 124.8. But what I discovered in the end was that the this distance between the engine block face and this surface needs to be 97 millimeters. That's a difference of 27.8 millimeters. And ta-da, that's the thickness that my flywheel adapter needs to be. And unfortunately, the flywheel adapter has to be on the front side of the flywheel. Fortunately, I have an aluminum flywheel, so the friction surface is steel, and I can unbolt it, move the friction surface this direction, put the adapter in there, and then put the friction surface onto the adapter, sandwich everything together, and then I'll need longer bolts for the friction surface. And the pressure plate will also be moved that same distance, 27.8 millimeters, this direction. So in essence, I'm making a thicker flywheel out of my existing flywheel. But like I said, that thickness is super, super critical. Get it wrong, and you'll either have a clutch that won't work at all, or you'll have a clutch that will work, but you won't get the full mileage out of it. So you got to get it perfect. It's that critical. So as you can see, I've got plenty of room for wear. So now I'll show you a test. So that'll be the next part of this video.